Alright guys, so in this new video that we have, this lesson is going to summarize what we had done for our icy hot lab. The essential question is, how does the temperature change as water changes phase? Okay, some key terms. First, we'll talk about temperature. Temperature, as you already know, is it measures the average kinetic energy of particles in an object or a substance. So if you have a higher temperature, that means the particles are moving faster. If you have a lower temperature, then the particles are moving slower. Okay? And we also talk about two different types of energy. One is called thermal energy, and that is the energy that's stored by moving particles. So they have to be moving for that. And again, if for things to move faster or slower, the temperature has to be changing. So it happens during temp change in your heating curve or cooling curve there. There's also another new concept, and that is something called a phase energy. That is the energy stored in the system due to the arrangement of the particles. So the way the particles are arranged spatially, so there's going to be a difference in distance between the particles, and that's how we're going to and that usually happens during constant temperature. If your temperature is constant, and or during those times as well, they are called phase change sections in your graph. Okay, so what is the result of your icy hot lab? Okay, well, it looks like this. You're gonna have a you had the ice, right? And you heated it up until it boiled. You had a diagonal line to 0, a flat line at 0, a diagonal line to 100, a flat line at 100, and you never really went up, but we are gonna assume that, it'll go up because that's the pattern. So therefore, our section 5 is going to be a diagonal line as well. So it looks like a staircase. Okay. Is this a heating curve? Yes. If heat is added, if temperature is going up, then heat is being added, so therefore this is called a heating curve. Okay. All right, so in order to summarize the icy hot lab, we're gonna use a table which hopefully you're gonna put in your journal, as it has a lot of information, exactly what you found using the icy hot lab. Okay, so I went ahead and put section 1, 2, 3, 1, 2, 3, 4, 5, depending on how the different sections of the graph. So let's go ahead and do some temperature ranges. So at 1, those are all less than 0. Anything less than 0. At 2, those are right at 0. There's no temperature change in there. 3 is going to be from 1 to 99, going up. 4, it's going to be right at 100. No changes in there. And then finally, from above 100 is going to be 5. Okay, and these are all Celsius. Once again, from our definition, whenever there's a change in temperature, so the change in temperatures are here. There's a temperature change in there, temperature change in there. Thermal energy is changing as well. So in this case, we're adding energy, so therefore we're going to have an increase in energy in here. I'm going to go ahead and call this is going to go up, this is going to go up, and this is going to go up. Well, what is happening to the thermal energy if the temperature is constant? Well, it's also constant. Okay, so this is going to be constant, and then constant right here. All right, so well, what about phase energy? Well, phase energy is the distance between the particles, okay? And during times where there is a temperature change, phase energy is constant. Here's what I mean by that. So this is constant. This is also constant. And this is constant right here. Whenever there's a phase change, so in this case, this is the melting, right? This is melting, and this is boiling right here. Well, if there is a phase change, the phase energy, the distance between the particles will increase, decrease, depending on if you're adding heat or removing heat. So in this case, this is when it is increasing. I'm going to go ahead and add going up and then going up in here. And then hopefully you'll see a pattern in there. What is happening at less than 0 degrees Celsius? Well, it is just solid. Okay? And then at 0, it is melting, so therefore both of them should be there, solid and liquid. This one is just liquid. This one is liquid plus solid. No, sorry, I misspoke there. So liquid plus gas, and this one is just gas. Okay, so how would we draw the particle diagrams of these? When, as you already know, solids look very rigid, so they have to be in shape. Okay, they have to have a definite shape, but there's still going to be some movement, so we're going to denote those. So these are called whooshies right here. Whooshies are ways for you to show, so right here, the green one right there, those are called whooshies. It's a way for us to show movement. The more whooshies you have, the more moving it is. Okay? And then once again, even if solids are not moving, they're still going to be vibrating. What if you want to show a solid and a liquid? Well, I'm just going to go ahead and remove some parts in here and make sure that this is my liquid right here. And then what if I want to show all of them as liquid? Well, all I really need to do in that case is just have them, and I want to show my temperature to have increased, so therefore I'm gonna have more than one whooshy in there because it's showing the movement. And then how would I show both liquid and a gas? Well, I know gases tend to be faster and more definite, so I'm gonna have one that is up there, and this will be my gas right here to show that there is gas and liquid in there. And then finally, how would I show a gas? And that means definitely show a lot of volume and a lot of whooshies because of movement. Okay, and this is how to fill in the table for the ISAT lab for warming. Okay, so how would we do it for cooling? Well, if you're cooling something, you're removing the heat from the system. Okay, so how would you draw the cooling curve? The cooling curve is very simple. It's just the opposite of what it looks like if it was heating. So I'm gonna go ahead and draw a flat line here. Let me get a line. Flat, the diagonal going down, a flat line to 100. That is the condensing phase because it's going from gas to a liquid. Then you're going to go all the way to 0. That's when it's all liquid. You're going to freeze it at 0, and then it's going to go down for just the solids. Okay, so looking at it this way, where I'm still going to call this number 5 because it's just easier that way. This is 5, 4, 3, 2, 1. So in my table in here, I'm going to start at 5, okay? At 5, it is above 100. At 4, it is right at 100. At 3, it is from 99 to 1. And let me just fix that to 1 degree Celsius in there. And at 2, I'm at 0. And then at 1, I am at less than 0. Okay? I'm going to go ahead and do the same thing as what I did on the last page. I know that thermal energy, when there is a change in temperature like here, I know that my thermal energy will change. But in this case, since I'm removing thermal energy, this is going to go down instead of up like the last time. Okay? During phase change, the thermal energy is constant. So I'm going to go ahead and call this constant and constant. During phase change, there is an increase of there's an increase of phase energy. Oh, actually, this one is decreased because you're actually you're cooling it, right? So it's gonna look like this: constant, constant, and then another constant. What about the phases? Well, the phases are pretty simple as well because we just need to go backwards one last time. That these are your solids, right? Actually, let's go backwards because that's how we drew it in there. So 5 are all gases. So this is liquid and gas. This is just liquid. This is just liquid and solid. And then finally, there is going to be our solid in here. Drawing it is going to be simple as well. We're going to go with the gas first. There's going to be a lot of movement first. So I'm going to go ahead and throw it in here. And then these are my gas particles. All right. And if I were to draw a gas and a solid particle and a liquid particle in one box, I'm just going to make sure that one of them is going to go closer. So this now is going to be my liquid right here. This is liquid. Okay, so how would I show all liquids? Well, if I want to show all liquids, all I really need to do is draw my circles a little bit closer together, but not that close that I'm going to show a solid. And if that is the case, then I'm just going to have, so those are all liquids now. So if those liquids, then it's just going to be 2 whooshies. And then finally, how would I show solids and liquids? I'm going to have for my solid and then a liquid maybe. So this is how it's going to be. And then finally, all solids, I'm going to need to make them all at the bottom there and with 1 whoosh. So again, for this one, where is my, I just need to make sure that you actually, when you do your exam, you're also telling me what phases there are. So this is my liquid right here. All right, so I hope that is making sense. So in the your turn, you're going to be exploring a different type of heating curve. You're going to explore the heating curve of sodium chloride, which is stable salt, okay, which has a very different heating curve. And then the first question is going to ask for where is the solid, liquid, gas, where is the melting point, what is the boiling point, what is the phase of NaCl at room temperature. I think you already know that. And then what is happening for the thermal and the phase energy for sections 1, 3, 5, and 2, and then 4. Should you have any questions, please let me know. I'm always available for you guys.